Welcome to Honeywell's Training on Demand. This program will explain how we use an intermittent pilot to provide burner ignition for a gas heating system. We'll cover theory of operation, the hardware that's used, and then talk some about service techniques that will help you find problems faster. Intermittent pilot ignition was first widely used on residential heating equipment after the energy crisis in the 1970s. Cost of natural gas and other fuels went up rapidly, and many were concerned that our supplies of fuel might be in jeopardy. In parts of the country, laws were passed to help reduce gas consumption. Some of the things outlawed were decorative gas lights and standing pilots in furnaces. It turned out to be fairly easy for a manufacturer to convert a standing pilot furnace to an electronic intermittent pilot furnace. The main burner is still lit by a pilot, and that pilot can be very similar to the old one that had a thermocouple. Little or no additional safety testing was required for this modification. And on average, it gave us a 5 to 6% reduction in annual gas usage. Intermittent pilot control is accomplished with a special pilot burner that has a spark electrode to light the pilot, and sometimes a separate electrode to detect the flame when it's burning. The electronics needed to generate a spark, detect the flame, and control the gas valve are in this module. The module connects to the pilot electrode with a high voltage cable like the spark plug wire in your car. So, just exactly how does an intermittent pilot work? Well, intermittent means part-time, and that's a pretty good description for this control scheme. The pilot's only on part of the time. Take a look at this. A high-voltage electric spark lights the pilot when there's a call for heat from the thermostat. At the same time the spark is turned on, the pilot gas valve is also opened. The pilot lights right away, in just a few seconds. Within another second or two, the electronic controls determine that there actually is a pilot flame burning. We call this flame detection, or proving the flame. Now, with a proven pilot flame available, the main gas valve opens and the main burner lights. At the same time, the spark ignition is turned off. Both the pilot and the main burner remain on until the call for heat ends. Flame proving utilizes a process known as flame rectification. 2 electrodes are placed in the pilot flame. The electrodes are connected to a voltage source, an alternating current voltage source. If a flame is present, a small amount of electrical current will be conducted from one electrode to the other through the flame. Now, because one electrode is much bigger than the other, more current flows in one direction than the other. The current flow is effectively rectified. A couple microamps of direct current is interpreted as a flame being present. This is a fast, very reliable and safe method of detecting flame. It's used almost universally in modern burner control systems. Now let's continue with the intermittent pilot sequence of operation. What happens if the pilot flame does not light? Well, there are a couple of different possibilities. In the past, we used some intermittent pilot controls that tried continuously to light the pilot, at least with natural gas. That was referred to as non-lockout. This sequence is not used today. Today, the burner control limits in some way the length of the trial to light the pilot. One way is to simply time how long the spark and pilot valve are energized before the flame must be proved, for instance, 90 seconds. If the pilot isn't detected in 90 seconds, the control locks out and prevents further operation. The control system used by Honeywell combines the first 2 methods into a new sequence of operation called continuous retry. If the pilot fails to light in 90 seconds, the trial stops. After a wait of 5 minutes, another 90-second trial occurs. This sequence, trial and wait, continues indefinitely. Now that we've explained the basic operation of intermittent pilot, let's look a little more closely at some of the hardware and other details. There are 2 different types of pilots used with these systems. One type has 2 separate electrodes for the sparking and sensing functions. To light the pilot gas, a high voltage spark jumps from the spark electrode to the burner hood. The flame sensor, or flame rod, works with the ground strap and the pilot hood, which are both grounded, to detect the pilot flame using the principle of flame rectification. There are two wires leading from the pilot to the ignition module, one for sparking and one for sensing. The other commonly used pilot has only one electrode that does both jobs. This Honeywell innovation simplifies the control system for intermittent pilots by reducing the wiring required for installation. The ignition module it gets used with is designed for just one electrode. Here's how that works. We're looking at 2 cycles of the 60 Hz power supplied to the flame sensing circuit. Because the current in this circuit is rectified by the flame, the bottom half of the waveform is gone. Current only flows during the positive half of the cycle. During the other half of the cycle, we introduce a very short high-voltage spark. This spark occurs 60 times a second, so it looks continuous. That's how we can have 2 signals, one a microamp flame sensing signal and the other a 20,000 volt spark signal in the same circuit at the same time doing different jobs. Intermittent pilot systems use an electronic module like this Honeywell S8610 to sense the flame, provide the spark, and safely sequence the burner. This particular module is the S8610U. The U designation means it's designed for universal replacement service applications. It came about because of the need to replace hundreds of modules originally installed on gas equipment by the manufacturer, but no longer available for repair work. The S8610U replaces over 300 modules from both Honeywell and other control manufacturers. You can use it to repair almost all the modules on an installed base of 10 million intermittent pilot heating systems. It works with both natural and LP gas systems with either 1-rod or 2-rod pilots. To use this module with a 1-rod pilot, simply connect the spark wire to the spark terminal. A jumper wire connected to the sense terminal delivers the flame signal to the logic circuits inside the module. When we use the S8610U with a 2-rod pilot, we unplug and cut off the jumper wire so we can connect the wire from the flame sensor to the sense terminal. When mounting the module, you can install it in any position except with the terminals pointing up. That's to keep water from a leak or condensation from accumulating inside the control. The rest of the wiring is pretty straightforward. An intermittent pilot valve requires 3 wires, one to power the pilot valve, one to power the main valve, and a common wire for both circuits. In order to make the flame rectification process work properly, the module must be well grounded to the pilot burner. There is a ground terminal on the module to do this. And then we have to supply a call for heat signal from the thermostat to start the burner. The grounded side of the 24-volt transformer connects to a terminal called 24-volt ground. The thermostat signal connects to a terminal called TH-W. There's also a 24-volt hot terminal, but that won't be used unless we're hooking up an automatic vent damper. This control is already set up to connect directly to a vent damper, such as might be used on an atmospheric boiler to improve its efficiency. You just remove this plug, and you can plug in the vent damper cable right here. All sequencing, safety, and interlock functions are wired correctly through the plug. Now, the most important thing about choosing a universal replacement control, especially a safety control like the S8610U, is knowing for certain that it'll work and that it's safe to use in your application. All of the approved applications are clearly listed in the literature. Exact model numbers are given for older Honeywell controls as well as those of other manufacturers. And since not all controls manufacturers use the same nomenclature and terminal designation, the instructions also include terminal cross-references from old to new. Remember we mentioned that converting from standing pilot to intermittent pilot was an easy job for furnace manufacturers? Well, the same is true in service situations. There may be cases where it's desirable to replace a standing pilot with an intermittent pilot to solve a service problem. There's a kit to do this. It's called the Y8610U. In it, you will find an ignition module, a new intermittent gas valve, a wiring harness, and a special igniter sensor assembly. First, you remove the old thermocouple from the pilot and replace it with this ground rod. It has the same threads as a thermocouple, so it fits perfectly. Then the igniter sensor assembly fits over it and is automatically positioned exactly where it needs to be to both light the pilot with a spark and sense the pilot flame electronically after it lights. Intermittent pilot adds speed of response and energy conservation to modernize an older heating system. Another valuable replacement component is the VR8345 Universal Electronic Ignition Valve. It's the perfect thing for your truck stock because it replaces gas valves on virtually all electronic ignition heating systems, both intermittent pilot and direct burner ignition. Out of the box, the valve has a plug in the pilot outlet, so to use it on an intermittent pilot system, you remove this plug and hook up the gas tube going to the pilot. It's got 3 electrical connections, one each for pilot valve, main valve, and common to hook up to the 3 wires going over to the control module. Now, on a direct burner system where there is no pilot, we leave this plug in, and we use this electrical adapter plug to give us the 2 wires we need to connect it to the direct burner module or circuit board. This adapter simply jumpers the leads to the 2 internal valve operators so they both open at the same time. One part that does a couple of functions. You have fewer parts on your truck, and it's more likely that you've got what you need to get your customer comfortable quickly and efficiently. Now, just a word about troubleshooting intermittent pilot systems. Based on what we hear on our telephone hotlines, the most common problem with intermittent pilot systems is a failure to prove the flame during light-off. In most cases, this means that the flame signal is not getting back to the module. The symptom you'll see is that the pilot will light, but the spark won't turn off, and the main burner won't light. The module doesn't know the pilot is lit, and so the sequence stalls right there. The circuit that carries the microamp flame sensing signal has 2 parts. The first part is the spark or sensing wire. Check continuity from the flame rod to the sense terminal on the module. The second part of the circuit is the connection from the pilot burner to the ground terminal on the module. This is very often the problem. Check this circuit by using a jumper wire to provide a good ground circuit. Run it from the ground terminal on the module to the pilot burner bracket. A lot of the time this solves the problem. If it does, put in a new permanent ground wire. It's also possible for the flame rod to get dirty so that it can't conduct the flame signal. You can clean it with some fine steel wool or a kitchen pot scrubber, but don't use anything too abrasive or you can do more harm than good. Well, that's our story about intermittent pilot ignition systems. Thanks for viewing this Honeywell Training on Demand program today. We hope it'll prove helpful on your job. Printed reference material is available for this lesson. For information on that and other subjects in this series, contact Honeywell. And remember, Honeywell has a hotline where you can get technical assistance on tough troubleshooting problems.